So now we're looking at quadratic functions, but we're going to use the same principles that we've been using this entire lesson. So don't let the wording confuse you. It's just adding a couple extra steps, and that's all it is. So we're asked first, we're given f of x equals x squared minus 2x minus 8, and we're asked to find x when f of x equals 7. So this is just simply setting up the same type of problem that we've looked at this entire section. X squared minus 2x minus 8 equals, we just substitute 7 for f of x. So 7. And now it's just the same problem we've been looking at this entire section. Subtract 7 from both sides, we get x squared minus 2x minus 15 equals 0. So now we're going to factor this. We know the leading term is going to be x in both binomials because it's x squared. Now we want to know what multiplies to negative 15 and adds to negative 2. So if we look at 3 and 5, that's a difference of 2, and we want the bigger one to be negative because we have a minus 2, so this is just going to be x minus 5 times x plus 3 equals 0. And then x minus 5 equals 0, or x plus 3 equals 0. According to the zero product property, we know one or the other of them is going to equal 0 in order for the product to equal 0. So x equals 5, or x equals negative 3. Now to check these, we could substitute them back into our original equation, but just take my word for it that they are a solution in this case. Now the second part is really easy at this point because we just solved for x when f of x equals 7. Well, x and f of x then is y. So x equals 5, y equals 7, x equals negative 3, y equals 7. And in a quadratic, that's typically what you'll find is that there'll be two x values that share the same y value because a quadratic represents a parabola. So as far as finding the 2 points on the graph of the function, that just means x, f of x, and we just solved for 2 of those. When x equals 5, f of x equals 7, and when x equals negative 3, f of x equals 7. So here's the 2 points on our graph. So again, when we're given a value for the function itself, we just set the polynomial, in this case a quadratic, equal to the value that we're given for the function. And then we just simplify using the same process that we have this entire section. Put it in standard form, factor, use the zero product property to solve, and then 2 points on the graph of the function just means whatever you solve for x, we know the output is going to be whatever we had given to us that the function is equal to.